Hello everyone, my name is Amanda Jorgensen.
I'm Erica Liu.
And my name is Hope Raveche, and this is our presentation on the impact of microscopy on neurological and psychiatric disorders. So, how does current fluorescence microscopy affect neurological and psychiatric disorders? Well, many people around the world are impacted by diseases such as Alzheimer's, Parkinson's, depression, etc. And the Brain Initiative has done years and years of research on this. However, we believe that extensive use of fluorescence microscopy can bring us closer to cures for these diseases. We believe that a pre-diagnosis approach would be extremely effective and would enable us to identify any signs of the illness before the symptoms start setting in. So fluorescence microscopy is a type of microscopy that enhances species and creates clearer images for thorough examination. So the process goes that the use of dyes as well as a high energy light excites the specimen, which results in the specimen emitting a low light energy, which then produces an image that is cleared and has intensified features for extensive examination. So this type of microscopy has already been used in multiple sciences, such as the neurobiological sciences, and so we believe that a neuropsychiatric focus will expedite the process of finding cures for these diseases.
Making a breakthrough in how we treat neurological and psychiatric disorders with nanoscale microscopy has the potential to change the lives of many. According to a study made by the UN World Health Organization, around 1 billion people are affected by these disorders, and that's around like 1 in every 6 people in our world's population. So with such a large number of people, we think that being able to use nanoscale microscopy will be able to change the lives of the many. We hope that being able to utilize this technology in pre and early stage diagnosis will be able to treat them from the very beginning, and also discovering elements that are related to the disorders like gene and chromosomes. So there are multiple types of dementia which make it difficult to identify the exact cause of the illness, and if we're able to use this technology to look closer into it, we want to be able to look deeper and find out what can differentiate them.
So right now, not much is known about how these illnesses are caused or how they can be cured. But what we do know is that these psychiatric illnesses, they progressively get worse as time goes on. So right now, treatment focuses more so on slowing down the progression and kind of stopping it at where it's at. But so far, we haven't been able to cure all of the effects of the illnesses that have happened so far. And so right now, scientists are attempting to pinpoint the certain brain circuits that are associated with these illnesses by stimulating regions of the brain to better understand how these illnesses kind of affect the brain as a whole, which may lead to a more effective treatment. And then in 2016, Professor Marcus Sauer from JMU and his team, they wanted to tag proteins that were related to these psychiatric illnesses. And so they originally used antibodies, but the issue with antibodies is that because of their size, they are much larger than the proteins they wanted to tag. The images that came out were not clear. They were blurry images, and so they were not able to get conclusive results from them. And to overcome this, they teamed up with the University of Copenhagen, and they created peptide probes. Peptide probes work because they are much smaller than the antibodies that were originally used, and therefore the images that result from it are much clearer, and they could get more conclusive results from it. So far, the results have been promising.
So essentially, our project takes a pre-diagnosis approach, meaning that we want to pinpoint the disease before the symptoms actually start setting in. And so to do this, we'd be using peptide probes to identify certain brain regions, as well as proteins, cells, genes, anything that could point us in the direction of explaining how and why these diseases affect people as they do. And so peptide probes would be very effective because they're small enough to produce very clear images, as well as attaches very effectively to the specimen in question. And so we believe that this can make significant progress that will positively impact the Brain Initiative and the research they've done in the past. And so with these innovations comes setbacks, and so one of the possible obstacles that we'd be facing is that current fluorescence microscopes cannot provide spatial resolution below a certain diffraction limit, and so the difficulty comes in that different species have various limits, making it very difficult to pinpoint one exact diffraction limit for all species. Another obstacle is that observation of living specimen is much more difficult than that of the deceased. So normally when observing a living specimen, it would result in a either too faint or too bright non-specific autofluorescence, making it practically unusable and inobservable for research.
And just to summarize, we want to use fluorescence microscopy and peptide probes to pre-diagnose brain disorders, and this will address the Brain Initiative grand challenges. And we want to aim to help the millions of people that are affected by these neurologic and psychiatric diseases.
Okay, and then contributions and references. So we're opening the discussion to questions. It's very similar to what we're trying to do. They're using it to identify certain proteins and the effects of it on the body, and so we believe that if we were to use the same peptide probes on neurological and psychiatric disorders, it could have the same effect in identifying what and how things cause effects in the body.
Yes. So if you're using it to like pre-diagnose, how would you be getting the samples to like test it on? Like, would you take it like from a spinal tap or like a biopsy?
Well, what we could do is that we could use patients who already have the disorder and see what they kind of have in common, and then maybe we could use maybe one of their relatives or something, since it's likely connected to genetics. Maybe we could see if they have that same gene or chromosome as well.
Yes.
What got me interested is that PTSD and all that stuff. I thought it was mostly more environmental type thing, but is it more like dealing with heredity, genetics? That's why some people are more prone to get PTSD soldiers.
It's definitely environmental, but a large part of it is maybe due to some genetics. Some people may be more likely to get it than others.
So then genetics probably plays a part then.
Yes.
So our project addresses both neurological and psychiatric disorders, meaning PTSD in the psychiatric disorders. So essentially, even though it may be having to do with genetics and it may be having to do with environmental effects, we're essentially using the peptide probes for the same thing. We're trying to identify what is going on in the brain and how it affects the person as a whole.
I think we have time for one question from our instructor, your TA, and then can you read that question?
I would have been interested in understanding how a peptide probe actually is specific to, how do you make the probe specific to a specific disease?
Okay. So there have been studies in Singapore, in a Singapore consortium, making new models for these probes to have the specificity to identify and make sure that what we're trying to look for is exactly what we're getting. And so using these new models of the probes, we'd be able to identify a gene from a gene and a chromosome from a chromosome with no mistake for switching them up.
Thank you, guys. Thank you.